some example problems. And this should be a little bit of a, okay, I think I get it. Here we go. So we got this sinusoid. We know that our good friend y equals cosine of x looks like this. Starts up here, goes over the origin. Quirky, but seems to work. And that's it. If you don't trust it, go to Desmos. If this is just this window, Desmos will probably show you the rest of it. It goes on forever and ever. Now let's take a look at this and do what the author wants. Just answer the questions. So what's the absolute value of A? Well, that's absolute value 1/2, which is 1/2. Now let's take one step at a time. The problems in your homework don't say graph, but I'm going to request that you do on 1 or 2. So amplitude down to 1/2, that stays, that comes up, that stays, that comes down. So that's how you flatten or vertically compress the graph. Now, let's talk about the normal period. Remember, it's always, always, always 2 pi. That little hint is given to you in the period formula. So if you ever wonder, well, what's the normal period? It's right there in the formula. Well, now we got to implement this, 2. So that's 2 pi all over 2, which reduces to just pi. So here's the thing. I like to think of this as a wall, and the wall has to come in. Remember, the wall, this wall, and this wall is originally 2 pi. I need it to be 1 pi. So this has to come all the way in here. I'm going to draw a dotted line here and use my old noggin. I'm focusing on the red portion of the graph. That thing needs to be squished in here. So let's talk about this half. It needs to go from 1/2 through 0 down to -1/2 in this half of the window. That half of the window is now right here. So this point slides over here. This point slides over here. And then I've kind of got the look of that half. I got to put a little curl in it, make it look like a tulip. You go like this, it just doesn't look like a cosine graph. So it's kind of like, and you'll get better at that the more you do. And then I got to duplicate this half in, oh, that should have went to here, in this window. So that would go like that. So there's the graph. Throw that in for free. But let's talk about the frequency. Frequency is 1 over the period, which is pi. So this final purple tulip goes through 1 cycle in the window of pi. That's all I'm saying. Now this drawing's not great. I got to make it great. There, now it's great. One more example. Here we go. Here's our sinusoid. This one we're going to leave alone. I'm going to explain that to you in a minute as far as graphing it goes. And you might say, oh, you're afraid, Mr. Kleefish, because you don't know how to do it. No, you're afraid. So, anyways, if you're curious about what this looks like, go to Desmos, check it out. I'm explaining why it's a little wonky and why I'm not going to try to graph it. I would probably confuse myself, therefore confuse you. I'll talk about it, but here we go. Let's just do what the author wants us to do. Find the absolute value of A, so that would just be 4. What's B? See, normally there's a 2 there. And if I put it in that formula, it would cut the period in half. Or there's a half here. And then I put it in the formula and it would actually double the period. See, if I have a number of some sort, a fraction or a whole number, I can kind of process that. But here I got pi over 4. They're just kind of messing with you a little bit. It'd be very difficult to precisely graph this. We're going to follow the formula. That is my B, because it's attached to the x. So it'd be 2 pi all over B, which is pi over 4. Don't forget, when you divide by a fraction, you end up multiplying by the reciprocal. So I'm going to get rid of that. And notice the pi's cancel. So I get 8. It's like 8. You know, all of these graphs are like pi over 2, pi, 3 pi over 2, 2 pi, or 90, 180. So what is this 8? Does that mean 8 degrees? No. Remember, this is always in terms of radians when you're graphing sinusoids, which represents degrees. In this case, when you use this formula, it always spits out radians. So you're like, remember 1 radian is approximately 60 degrees. So 8 times 60 is 480 approximately. So how are we supposed to get really precise with that on a graph? I think that's nearly impossible to do by hand. So we're going to stick with this. 8. Frequency is just 1 over period. So that'd be 1 over 8. 8 radians. So it's really 1 over every 480 degrees. So that'd be stretched quite a bit. But that's it. Boom. Go get that homework.